Pakistan is a profound blend of landscapes varying from plains to deserts, forests, hills, and plateaus ranging from the coastal areas of Arabian Sea in the south to the mountains of Karakoram Range in the north. Pakistan is divided into three major geographic areas: the Northern Highlands, the Indus River Plain, with two major subdivisions corresponding roughly to the provinces of Punjab and Sindh, and the Balochistan Plateau. At 796,096 square kilometers, Pakistan is the 36th largest country by area with approximately more than twice area than Japan. Three or mainly five rivers in Pakistan pass mostly through the Punjab province, therefore the name Punjab. Panj mean five and Ab mean water. The five rivers of Pakistan are Jhelum, Chenab, Ravi, Sutlej and Indus. Pakistan is the home of many mountains, like northern and western mountains above 7,000 meters. Five of the world's 14 mountains taller than 8,000 meters are in Pakistan, having a vast expanse of land stretching almost up to 8,000 square kilometers. Pakistan is the blend of distinct landscapes, snow-capped majestic mountains in the northern areas where glimpses of five top peaks above 8,000 meters is certainly a sight to behold. Rugged plateaus of Balochistan lie in the southwest and Great Indus River that roughly bordered the rich plains of Sindh and Punjab provinces. National highways of Pakistan are a network of toll highways in Pakistan, which are owned, maintained and operated by the NHA under the Ministry of Communication. It maintains 12,131 km of roadways organized into various classifications, which crisscross the country and provide access to major population centers. N70 is an inter-regional trunk road serving as arterial transport route from east to west across the center of Pakistan. One of them is N70 that connects Multan in South Punjab to Quetta. It is a major route from east to west across the center of Punjab that eventually provides shortest route between Lahore and Quetta, stretching almost 254 km in Balochistan and 186 km in Punjab. Its total length is 440 km. N70 links Multan to Qila Saifullah via Muzaffargarh, DG Khan, Fort Munro and Loralai in Balochistan. After crossing Indus and Chenab rivers in Punjab, N70 ascends Suleiman Range through Kirdu Pass and then reach Fort Munro before leading to Rakni, Makhtir and Musa Khel region to Loralai and finally terminating at N5 junction at Qila Saifullah in Balochistan. The highway starts right after the junction of N5 in suburb of Multan and runs toward Muzaffargarh after crossing river Chenab and then river Indus to enter DG Khan. After DG Khan, it starts ascending to Suleiman Range and through Kirdu Pass and Fort Munro, it enters into Balochistan. The first town in Balochistan province is Rakni and then goes to Makhtir region after passing through Musa Khel region and then Loralai and finally ends near Qila Saifullah at the junction of N5. Traffic volume passing through N70 is more than 2,000 vehicles a day and it is increasing year by year. Particularly, Rakhi Guj and Pivata section of N70 is known as most critical section in terms of road safety due to very narrow roadway, very sharp curves, steep slopes in geometric condition and hazardous conditions such as unstable road slide slopes, rock falls and flooding of crossing rivers. These situations are causing not only serious traffic accidents and huge maintenance cost but also adverse economic effect by distracting logistic from N70, which is shortest route to connect east and west of Pakistan. Being a shortcut route between Lahore and Quetta, N70 serves as a traffic artery for more than 2,000 vehicles carrying people and goods per day. Due to ever-increasing traffic load, road safety in section of N70 between Rakhi Guj and Bivata had been an overdue challenge for National Highway Authority and daily commuters. A narrow carriageway, tight curves and steep slopes at an altitude ranging from 1000 meter to 1600 meter result in road accidents, traffic jams, landslides and collision with overhanging rocks. Traffic issues and huge maintenance costs forced traffickers to quit N70 for alternate routes. The project was proposed by NHA as implementing agency of the project to facilitate mobility of both people and goods between east and west of Pakistan by improving the road section between Punjab and Balochistan on the N70, thereby contributing to socio-economic development of Pakistan. To achieve the above project target, the government of Japan had provided loan amount of 15.5 billion Japanese yen to government of Pakistan through Japan International Cooperation Agency JICA in 2008. JICA has been providing assistance in three focus areas. 1. Ensuring human society and human development. 2. Improving the economic base. And 3. Stable, balanced development of Pakistan by flexibly applying in various schemes, grant, aid, Japanese ODA loans and technical cooperation. Sensing the gravity of socio-economic misery of the area, Japanese government provided 15.5 billion Japanese yen loan to government of Pakistan. Then government of Japan asked JICA, a globally well-reputed Japanese NGO that is known for its various human development works in the region, to implement the project. JICA's main focus in Pakistan has been impactful in the area of human society and development, improving economic base and stable development, such as undulating situation in this section of N70 obliged National Highway Authority to take stock of situation and waited for financial and technical assistance to come for a road safety project. CTI decide cooperation in the contractors selected from Japanese construction firm. JICA is providing many cooperation to Pakistan, not only financial cooperation but development of infrastructure, human resource development as well as poverty reduction. Japanese construction technology has been contributing infrastructure development in the all over the world. JICA is very much expecting this project will contribute the development of Pakistan. To plan, design and supervise the East-West N70 improvement project between Rakhiganj and Bivata, CTI Engineering International Company of Japanese engineering consultants was awarded contract to execute the plan, and other Japanese construction firm SI was selected as contractor of the project, whereas National Highway Authority was the implement agency of the project. As per schedule, 3-year project timeline was to expire in 2019. Engineering International Company Limited, who is Japanese engineering consultant, has been in charge of planning, designing and supervising of the project. Aim of all the planning conceived by CTI was to extend pavement of 6.7 meter wide 2-lane carriageway. Vertical gradient was to bring down to 6%, whereas 30% horizontal curve radius was purpose to avoid the tight curves and steep slopes in limited space. Show drawings and pictures customized application of Japanese technology including prefabricated steel widening, mechanically stabilized earth, foam cement banking, ground anchor work, rock fall protection wall, and steel box girder bridges were purposed to improve road safety to section N70 between Rakhiganj and Vivata. To take on construction challenge was never an easy task, but the unflinching resolve of experts involved made it look very easy and smooth. Erection of 7 steel box girder bridges reflect the subtle application of Japanese technology and a rare innovative advance. Initially at hilly slopes, excavation work was done to form deep foundation by placing steel liner plate. Afterwards, pillars and abutment were constructed on it to hold steel bridge girders. Customized fabrication of steel bridge girders at factories in Japan is a rare facility in its part of the world. For welded construction of steel bridges, anti-Korean steel was used in curved steel box girders as it repeats moderate dryness and humidity in the atmosphere. Eventually, it forms dense rust on the surface of steel that ensures lifetime protection. After fabrication process is over, these steel bridge girders are transported to the project site. Erection and fixing of steel bridge girders were made possible by using cranes. These giant steel structures are a novelty and a real feat of Japanese engineering wonder. For extension of pavement of 6.7 meters, solution was found to prefabricated steel widening technique. For this, customized fabrication of steel frames and pipes were processed at factory stage to shape up super steel structures to be used in widening carriageway. To fix these super steel structure along the pavement, drilling of the rocky slopes was done by down the hole hammer technique. Then steel pipes were placed in it like piers. Now the stage is set to erect prefabricated super steel structure. Finally, to fix them firmly, deck slabs were put in the place. To support unstable embankment in limited space, mechanically stabilized earth wall is another Japanese technology that offers quick solution. This technology has been evolved out of bitter earthquake experience in Japan. To apply this technique, excavation was done alongside of embankments, then steel skin panel was placed inside the support embankments by selected material. After this, installation of geogrid follows, strengthened shearing force of the earth embankment. Here, friction between embankment material and geotextile was avoided to construct flexible structure to resist earthquake. To widen sharp turns and tight curves, foam cement banking is another Japanese technology applied here. As per procedure, special mixing plant to foam cement was prepared. Then cement was mixed with chemical to create lightweight concrete. Then concrete panel of setup for pouring foam cement banking inside concrete panels. Ground anchor work technique was considered best option to protect unstable slopes. At project site, excavation was done at risky spots from drilling holes. In these holes, steel wires were installed and empty spaces were filled by grouting mixture of cement, water and solidifying materials. Then tensioning and encroaching is done to balance opposing forces. To address rock fall issue at rocky slope, shotcrete or sprayed concrete was used for bonding rock, steel concrete and other material to stabilize rock slope. Then the wire net is prepared to be fixed by nailing to complete rock fall protection netting process. To drain out rainwater box and pipe culverts are used to minimize the water effect on high road structure. All the construction work by TSI was carried out against all odds of unpredictable weather conditions. Especially pavement construction was severely hampered by heavy traffic passing by the site of construction. Considering such inordinate number of problems with the completion schedule, the time lapse is just negligible. However, the work schedule is very much likely to be complete by the end of December 2019. Now with each passing day, one can observe many changes along with the sight of 40 feet containers plying on the unhindered road. To completely turn around an undulating and risky carriageway into a safe route for commuters has been a long-awaited public craving over the years. Now it is a time for new beginning for all those who were affected on daily basis by hazards of traveling on such a tough high road. Improvement of N70 section between Rakhiganj and Bivata has opened up a new vista of unrevealing experience in Pakistan. Consultancy expertise of CTI speaks highly of its commitment, intensity of purpose and ingenuity. Pacing bosom of a tough highland to improve a risky passageway is certainly a Herculean task to take on, from mobilization of high machinery to fixing giant steel structure on rugged and unwelcome terrain. All tasks were achieved against all odds. Investing money and technology for the socio-economic welfare of remote area has been the hallmark and focus of JICA over the years. After all, the real bonus is the smile on the face of those who are being benefited by application of modern Japanese technology. Such independent geomechanics always have a positive impact on field decision and leave innovative footprints of Japanese technology. Enriching life through technology, a promised goal of JICA and associates.